short comment. So today we have to learn what contingency table is. And contingency table illustrates, so it looks like this. So, and in each cell we count total number of observations that belong to males and private, or females and state. Well, instead of frequencies, we can use proportions. Well, or we can use mosaic plot. So let's make a contingency table in Stata. Please, everyone, I uploaded into our chat a dataset BEEPS Stata 1211. Please open this dataset in Stata. Let's open BEEPS 1211 in Stata. And type plus if you are ready. Fine. Well, now we have to work with a real data set. If I describe this data set, I will see that I have different variables. Some variables are binary or are strings. Some variables are integer or float even. Well, this data set is a survey. It is a survey data, and it was a survey of firms in Russia. Well, this survey was conducted in 2011 and 2012 years, and this survey examined different firm characteristics and management opinion about corruption, administrative barriers, different issues related to business development in Russia, well, and so on. And today we want, for instance, to use this data to make a simple maybe contingency analysis. For example, we want to find a relationship between firm size and different attitudes or different behavioral patterns. For example, here we have a variable sampling size. So describe A6A. This variable shows us size of a firm. Well, and look, in our data set in total we have, no, it's not about Russia, it's about, this data is about transition economies. And we have micro firms, small firms, medium firms, large firms. Well, in total, we have 16,566 observations. Well, and if we look at the distribution of firms in our dataset, we see that half of our firms are small or micro. Well, 35% of our firms are medium, and just 12% of our firms are large. So this distribution is consistent with the intuition, because usually I think you know that most of firms are small firms, well, or at least half. Well, and so this variable is qualitative variable, and it can be used to make a contingency table. But to make a comprehensive contingency table, we need another qualitative variable. For example, it could be let's use something interesting. For example, C5 variable It shows whether a firm gave informal gift or payment to obtain electrical connection. I asked whether the firm gave a bribe. Well, and to make an contingency table, so we need to write two variables, for example, A6A and C5. Well, and if I do this, state will create a contingency table. Well, first variable is for rows, second variable is for columns. Please do the same and type plus if you are ready. Do the same and type plus if you are ready. Okay, fine. Well, next let's make this table better. Well, first, what kind of table we make? We made we work with a frequency contingency table because look, it is a number of observations and we have number of observations or cases in each cell. But what if you want to create a relative frequency table? Well, no, relative frequency means that we have to add percentages. But if we want to if we want to show proportions, we need to check how we need to make a decision how we want to calculate these proportions. For example, add an option row. This is a code. Add an option row and obtain the same output. Well, so no, first, what we have now? Now we have a frequency row percentage here. And we see that if we use row option state, use the last comment as 100%. Well, and we see the distribution of yes and no answers for each firms. For example, we see that just from this table, we can learn that 26% of micro firms gave bribes and just 12% of firms gave bribes to obtain electrical connection, 13% did the same among medium firms, and just 7% of large firms gave bribes. What can we say from this table? We can say probably micro firms, so the smallest firms, or maybe the smallest firms are at risk or they are at pressure of corruption to obtain electrical connection. Well, okay, but what if we want to calculate another proportions? What if I want to use the last row as a 100%? To use the last row as 100%, I want to use call option instead of a row. Please use call option instead of a row. Well, how to interpret such a pattern? No, first you can look at total row. Total row shows total number of micro firms, small firms, medium firms, and large firms. And percentages shows a distribution of these firm sizes in our sample. We see again that almost half of firms are micro or small, nearly 30% of firms are medium, and 60% of firms are large. And here, in fact, we can look at two relative frequency distributions. We see that, for example, those who gave bribes, so the distribution among firms who gave a bribe is a little bit skewed to the left side, and distribution among those who didn't give bribe, among firms who didn't give bribe, skewed to the right side. How can I learn it? I can learn it from this number and from these numbers. Look, this number is larger than this number, meaning that probably smaller firms, small micro firms are more likely to give bribes than larger firms, and so larger firms are less likely to give a bribe. Well, also we can combine two relative frequencies. We can combine columns and rows in the same table. Please use two columns and rows to make all percents. Well, and in addition to this option, we can also use another option. For instance, we want to hide frequencies. To hide frequencies, please use option no frequencies. And look, now our table is smaller because we removed frequencies. Well, this table is it is an example of a relative frequency contingency table. Well, what else? Well, imagine that you can make a frequency table, but what you have to keep in mind, you should keep in mind that all of these numbers are random because we use a sample, we don't work with population, hence our numbers are random itself. And once our numbers are random, we cannot rely, once our numbers are random, we have to make some test to check something. And what tests can we find? For example, no, first we can ask ourselves, okay, whether there is a relationship between probability to give between informal payments and firm sizes. Well, but here from these numbers, I see that probably small firms are more likely. Small firms frequently give bribes, and this frequency is higher than that of large firms. But my numbers are random, and probably another sample and competing survey can show me a completely different picture. And I have to take into account this fact that all of these numbers are random. And probably, maybe in other survey we can show that there is no relationship between sampling size and bribery. To check this, I have to do statistical test. Well, and let's speak about potential statistical tests and their intuition. Well, what is the logic of contingency test? Well, no, the simplest version of this test is a chi-squared contingency test. Well, here you can find formulae, and what is the idea of this test? Imagine that you toss two coins. So you have two coins, you toss them, and what probabilities to get heads and heads, or heads and tails, or tails and tails. I think probabilities are always the same, 0.25 or 25%. Well, but probability. But what if this exercise, or what if I imagine that if I get heads, so probability to get heads again by tossing the second coins is higher. Why if I assume that two coins are interdependent? Well, no, let me show it in Excel. Maybe it is easier to understand. Well, contingency and chi-square test. For example, again, I toss two coins and I have two outcomes, heads and tails. Well, probability of each outcome is 25. If I assume that tossing coins is if I assume that, so my coins are fine, IS probability to get a heads or tails is the same, 50-50. And if I assume that coins are independent from each other, hence chances are the same. Well, and what I need to do when I run a contingency analysis, well, I need in fact to compare my experimental, my observations. For example, this is expected data. I have to compare my expected data with real data. For example, here I have 10, here I have 7, here I have 9, and here I have 11. Well, it is frequency. Expected. And here I have frequencies. Well, I have to compare these numbers or their proportions with my expected proportions. Well, so again, the test works fairly simple. I have to calculate the proportion of heads and heads in my experiment, the proportion of heads and tails, all these cell in my experiment with its expected number, with its expected counterpart. If I see that these proportions, for example, if I see that proportions for this number and this proportion are different, and the same can be said about other cells, I have to reject null hypothesis. Otherwise, I cannot reject it. Now let me show it in my slides how to run it. So this test. Well, you have to apply such a formula. Again, look, you have to compare your expected frequencies with observed frequencies, divide squared. Well, and I have to divide it by my expected frequency in each cell. And next I have to sum all of these cells. Well, to calculate expected frequencies, I need to apply such a formula. Well, for example, in my analysis, I have here, for instance, 40 observations, 43 observations, 23 observations, 141. And if I apply my formula, my expected frequencies will be like this. Well, let me stress that expected frequencies doesn't require, the expected frequencies cannot be whole numbers. It can be numbers with some decimal points. It is fine because it is an expected number. Well, and my job now is to find differences, square differences between these two numbers and divide it by each number by so related expected numbers. Well, it looks like this exercise. And some of this formula is chi-squared statistics. Well, and what I have to do, I have to compare chi-squared statistics with its critical value. Well, so yeah, we discussed chi-squared tables, right? And do you remember chi-squared tables, dear students?
Yes.
Yeah, very good. So it seems that you're ready for the exam. Well, and so no, again, to find a critical value, you have to first to calculate degrees of freedoms. Calculation of degrees of freedom is pretty simple. First, you have to calculate total number of rows minus 1 and multiplied by total number of columns minus 1. So, and output of this product is your degrees of freedom. In my case, degrees of freedom is 1. Well, hence critical value is 3.9. Well, definitely it is smaller than the estimated chi-squared statistics. Hence, I have to reject the null hypothesis and conclude that these variables aren't independent. Well, let's do chi-squared test in Stata. So in Stata, this exercise is very simple. If you want to run chi-squared test in Stata, you should use an option chi2. That's it. Please use chi2 option. Well, now we see that Stata shows us the estimated chi-squared statistics with 3 degrees of freedom. Why 3? Because look, we have 1, 2, 3, 4 rows. 4 minus 1, 3, right? 4 rows minus 1 gives us 3, multiplied by 2 columns minus 1 is 3. Well, and next he applies our formula to calculate the estimated chi-squared test. You know that Stata, as any other statistical packages, doesn't rely on critical values. Instead, Stata estimates p-values. It is our p-value, and we see that this p-value is smaller than any usual alpha. Well, what does it mean? It means that we have to reject null hypothesis and our conclusion that these two variables aren't independent. There is a dependence between probability to give a bribe and firm size. Well, again, our test identifies that there is a relationship between firm size and informal gift payments, but we don't know whether this relationship is negative or positive, strong or weak. We don't know. But can we learn it? Can we know it? Yes, we can. Again, a piece of theory. Well, no, for sure we can apply contingency tables for larger, so we can apply chi-squared test when we have large contingency tables. For example, here I have 4 rows and 3 columns within that table, and so the intuition or the procedure is exactly the same. I have observed frequencies. Next, I have to calculate expected frequencies, and next I should compare. I have to find out how different my observed and expected frequencies are, and so to summarize this comparison with using a single number, and a summary of this comparison is my chi-squared statistics. If this number is large, so my difference will be larger. So as this number larger, the difference between expected and observed frequencies is larger. Once the difference is larger, the likelihood that these two variables are independent is smaller. So once this number is larger, it is more likely that these two variables are dependent on each other. So again, the idea of this test is to relies on a comparison procedure. We have to compare expected frequencies with observed frequencies. Well, for sure, comparison one by one isn't very convenient for us. It is better to use a single number to summarize how different these frequencies are. Well, and chi-squared test summarizes how different these frequencies are. Well, and if this number is small, hence our differences are very small. When this number is large, our differences are large. Well, and when our differences are large, we have to reject null hypothesis and conclude that these variables are dependent on each other. Well, and we have to apply for sure, or no, robustly speaking, we have to apply this procedure. We have to compare our estimated number with its critical value. But note critical value can be larger if we have more rows and columns. So what problems here we can have? First, we have some assumptions. Note that total number of observed frequencies cannot be less than 5. If you have small number of frequencies, you should unify columns or unify rows, or you should rely on another test. Now, in accordance to our textbook, please avoid cases when you have two small observations within a cell. Another case when you have another case when you want to find a relationship, strong or weak relationship between two variables, or to find whether your relationship is strong, please use the option, Cramer's way. Wait a second, let me show you this data. Please use Cramer's V option, this option V, to calculate how strong the relationship is. Note that Cramer's V lies within 0 and 1. It cannot be larger than 1, it cannot be smaller than 0. When Cramer's V is close to 0, it means that the association is weak, and when it is close to 1, it means that the association is strong. From our Cramer's V, we can learn that the association between two variables is weak. We usually use Cramer's V when we have nominal data, but for sure we can use it for ordinal data. Another variable or another option you can use in contingency table is tau beta option. What can we learn from tau beta? No, first of all, Kendall's tau beta is used when we work with ordinal data, because if our data isn't ordinal, it could be very difficult to interpret the relationship. For example, what numbers lie behind each option here? Here we have 1 and here we have 2. Here we have 1, 2, 3, 4. As our number is larger, so it means that firm is larger, and no means no, that no bribery. And hence, if this number is its variable is increasing and this variable is increasing both, we move to this cell. What does that mean? It means that if we observe a positive relationship between firm size and probability of so informal payments, in fact, we observed that so large firms are less likely. We observe that large firms give bribes with lower likelihood, and indeed, look, this this indicator is similar to correlation coefficient. It ranges from -1 to 1, so first it shows how strong our correlation is. We show that correlation isn't strong, but it is positive, meaning that large firms probably are less likely to that large firms seldom give bribes in accordance with our sampling. Well, in principle, that's all about basic analysis, but what about advanced tools? For example, no, for sure, here this example is too simple to be real. In reality, when you work with nominal data, you have some problems with variables, and first you have to prepare your variables for the first analysis. For instance, you want to find a relationship between firm size and variables, no, say what variable we can use, something interesting. What, for example, labor regulation, not inadequately adequated workforce, human capital. Well, and for instance, our country is, that's our country. And for example, when our country is Russia, well, not large firm, let's use something, maybe A3, not. This one. What? This is a typical case when we have a problem. Look, type of establishment and inadequately adequate workforce variables. What problems we have? First of all, if you look at the second last row, you will see that total number of observation, that total number of cases is extremely small. Well, here we have 0, 1, 1, 2, well, and also we see that here 8 is also, by the way, pretty small number. It's not very, it's larger than 5, but it's not very different from 5. Well, what should we do in such a case? No, in such a case, we have to unify either rows or columns. And one student asked me, how can we unify rows or columns? Let's start with the most intuitively clear way when we unify rows. We have to unify what we do usually. Usually we have to find what rows can be unified. To do this, we have to use A8 if country Russia. Yeah. Well, establishment physically separated from something, establishment physically separated from something. Well, to find full labels, we have to open codebook. Well, and I think that these two options are similar as well as these options probably. And what I can do, I can try to unify the last two rows. To do this, I have to generate a new variable, for example, type being equal missing. So I created a missing variable. Please do the same. Next, I have to copy and paste some cells from my original variable. To do this, I have to replace my type variable with 8. For this, first I have to look at codes behind each option, no label. 1, 2, 3, 4. What I have to do, I have to copy and paste 1 and 2 options from 8 to type, and I have to unify 3 and 4. To do this, I should replace my empty cells in type variable with values of A8 variable if A8 variable equals 1, if country yeah, and country Russia. Well, two conditions. First variable equal 1 and country is Russia. Look, I have 77 frequencies here and I made 77 real changes. Well, it means that everything goes well. I replaced all necessary values. Next, I have to copy and paste these numbers from A8 to type variable. Do this. And look, my output must be 146 real changes. Look at your type variable. 1 and 2. And what else? Next, we have to unify 3 and 4. And when we unify 3 and 4, you should replace type with 3 if A8 is 3. And replace type with 3 when 8 is 4. Right output must be like this. Plus. Obtain the same output if you are ready, type plus. In the same table, if you are ready, type plus. If you made a mistake, you can delete your variable. To delete your variable, use drop type. Drop type is for removal. Well, next we see that we have numbers. But if I summarize the original variable, I will find labels instead of numbers. Is it possible to assign labels to these numbers? Yes, it's possible, and let's learn how can we do it. There are two ways to assign labels to each variable. First way is manual way. We can use, you should find variable manager button. Please find this button and click on it. Wait. Click on variable managers button. It is here. Well, what we have here we have a list of our variables, and in this filter I can type A8. Well, this is our variable, its type, its format, and value label A8. In this window, I see its properties and name of its value label. If I click on Manage button, I will find a list of different value labels. I have to look. I have to my value label here. Its value name of its value label is A8. I have to find A8 here. If I open this list, I will find value labels. Look what I have here. Here I have full names of my labels. HQ without production and sales in this location, HQ with production. Establishment physically separated from HQ and other establishment of the same firms. Establishment physically separated from HQ but with other establishment of the same firms. Well, I cannot assign this label to my new variable because here I have 4 values, but I created a variable with 3 values. But I can, well, make a double click on each label, copy this text to my notepad. For instance, it is my value 1. It is my value. And what about value 2? I have to make a double click here. Copy and paste to apply to my notepad. And value 3 is just, I don't have to copy and paste the whole text. Look, and I want to assign a label establishment physically separated from HQ, and doesn't matter, and details doesn't matter. Well, plus do the same exercise and type plus if you are ready. Do the same, copy and paste your list of possible value labels. Type plus if you are ready. To open this window, you should click here, Manage. Look, variable managers, find our variable A8 and find here value label, Manage. Once you click it, you will find a list of value labels. You have to find the same variable name, A8, and double click on each. Let's wait a little. Well, next we have to assign we have a list of numbers and related labels. We have to assign these labels to numbers. To do this, we have to find our new variable type. In your field of type into type, and look what we have here. First, in column label, we see that this column is empty. We can fill this space, label type of establishment new, and click apply. And look, once I click apply, Stata fills this space with my text type of establishment new. Well, now this variable has a own label, own short name, long name. What about value labels? To create value labels, we can find the existing value label here, or we can click. If we don't have the existing value label and we don't have it, we should create it. To create it, you have to click Manage and click Create Label. And look, first you have to enter a label name. Usually we enter the same names as our variables, but with caps. For instance, type with caps. And here you have to type value 1. If my variable takes 1, I want to see this text and click add. If my variable takes 2, I want to see this text. Add. If my variable takes 3, I want to see this text. Add. And next I have to click OK and apply. Please do the same. Enter here number 1 or 2 or 3 and related text. Click OK. Look. And here you have to choose this variable. We have it. Yes, fine. Well, and here I have to find my new value label, type, and apply. Look. Now I have here type. Well, and look, once I do all of this stuff, I can tap type and I will see text values instead of numbers. Again, how to create a label? To create a label, you should click Manage, click Create Label, and you should fill this space with a label name. It should be your variable name with caps. And you have to enter if value is 1, my label is something. If value is 2, my label is something. If value is 3, my label is something. Don't forget to click add. And OK. Click OK and choose a value name of a value label here and click apply. Please do the same and press plus if you are ready. Or tell something if I have to show it again.
May I ask a small question?
Yeah.
After we created everything, our labels and so on, we created our type, and we should apply our type, yes? And after that, print tab only, yes?
Yeah. Tab
Okay.
and variable name.
Thank you.
Code is here. Shall I go next? Well, okay, well, now we created variable and now we can run our contingency analysis. Well, I can copy and paste this code and look. Now I see that in each cell total number of cases is larger than 5. In principle, now I can run chi-squared test. Well, but for sure it cannot be very reliable because here I have total so small number of cases, and in principle here too. How to fix this problem? It makes sense to unify columns here. When we unify columns, we follow the same procedure. For example, in this variable, I can unify first two columns and I can unify first the last two columns. My decision about unification is made on the basis of meaning. Well, no obstacle or minor obstacle can be unified in terms of meaning. So it doesn't make sense to unify no obstacle and very severe obstacle because it is hard to understand, to interpret what this value means. Well, but the procedure itself is exactly the same. Well, but it could provide you with a little bit different output or even smaller p-value. Well, in principle, that's it, guys, about contingency analysis, chi-square test, grammar speed, now better. I think, and that's all about new material for this lecture. This is our last lecture. And to summarize all topics from our course, let me tell what can you learn more in addition to this material. For sure, it is always interesting to learn how to find the required sample size. And you have, well, we didn't cover this topic because because we don't have a sufficient number of hours of teaching hours. Well, but itself is very interesting, especially important if you want to design a survey, because if you want to run a survey, you have to find out how many persons you need to survey to make your analysis and tools reliable. But for example, today we learned contingency tables, and we see that when we have too small sample sizes, so we cannot run chi-squared test, and hence if your survey covers small number of respondents, you cannot analyze the collected data. Also, it could be very interesting to learn non-parametric statistics. You know that it is possible to compare averages, variances, but also we can learn how to compare medians. We can compare medians with a median with a single number. We can compare two medians, or we can compare several medians if we work with Kruskal-Wallis test. In Kruskal-Wallis test, it is a non-parametric counterpart of ANOVA. Well, also it is always interesting to learn more about correlations, because for sure we learn Pearson correlation coefficients, but there are non-parametric correlation coefficients, as Kindle and Spearman correlation coefficients, which can be applied when our when our variable doesn't follow, when our variables don't follow normal distribution. And in addition, there are more statistical tests that check whether your distribution is a normal one, like Jacobi-Rho or Kolmogorov-Smirnov test. Well, for sure, we learn just basics of statistics. We learn the most popular and frequently used tools. Well, in principle, you can find the course with the same content on Coursera or edX or probably other courses. And for sure, there is a large branch of statistical theory covering interesting and advanced topics like bootstrap and probably cluster analysis and so on, but they are beyond from our course, and itself they require an intermediate statistics course, which isn't offered in HSC and in your program too. Well, but this knowledge for sure is sufficient to run basic statistical analysis. And what you have to remember, you can apply descriptive statistics tools when even you have a population data, but if you have a sample, you should run different hypothesis tests to check to find confidence intervals, to check whether your averages or variances are different from numbers or other statistics. Well, and I think that's it. A few words about examination procedure. Please, in examination, be ready to show us your knowledge of theory, assumptions, and be ready to show that you can apply tests in Excel or Stata, or be ready to interpret Stata outputs. And in principle, that's it. And also, yesterday I uploaded sample questions to LMS, to Teams, because LMS still cannot, it doesn't work for some reason. I don't know why. But you can find sample written test and oral exam test in MS Teams. And on Monday, we will tell you what students are eligible for aftermath. And if you know that your aftermath cannot be smaller than 8, it cannot be larger than 8. Well, if you agree for this mark, please inform us before the exam. We will provide you with the necessary details. Now, your questions.
I have one question about expected values. For example, if I don't do my exercises in Stata,